Welcome to my video. Today a new video. We will do some final tweaking on the rear section of the chassis so we can start fitting the battery pack, and that's also in this video. And we need to do some minor modifications to the chassis to allow a good battery pack fitment. And today is also my birthday, so that's also something. I'm turning 34 today, so that's an achievement. So let's get started. So first off, we basically designed the lower section of the chassis, and we also designed the dashboard panel basically. What I failed to mention last time is that I also mounted some holes in the dashboard for lights like park brake light, blinker lights, etc, etc, so that at least you can see what's going on through the steering wheel. Now what we are going to do is have the left and right bracing in the car. That basically also supports the back of the seat. And yeah, as I mentioned, we are going to make some small adjustments to fit the battery pack properly, and one of the things is the lower box basically that we made to fit the chassis, the batteries underneath the seat. Those batteries need a little bit more space up top, so that the wiring can go through and some of the heat can dissipate away. Therefore, we want to have a little bit more space, and I had to change the bracket a little bit. Yeah, well, that's all in this video, so keep watching. As I mentioned in the introduction, we're going to do some left to right bracing basically. The lower side, we made some big basically big structures going to the front, and now from the left and the right we need to connect these structures so that the forces that are entering the chassis in the side impact, for example, that they can be transferred over to the other side to disperse that energy throughout the chassis. So the first thing that we are going to do is make a backing plate at the rear, and this backing plate should really ensure that we can get the stiffness of the profile that we are trying to get into this this body or this chassis profile. We need to stiffen that up with some thick material. So what we are doing is we are making an angled profile that we insert at the front, and then a 90-degree angle profile that we insert behind it, and those two elements will be welded together into a very rigid structure, which also allows the forces to flow towards that backbone underneath the seat basically, and to transfer over from the left side to the right side. And later on, not in this video, but later on, we will also do this similar thing around the dashboard, where there will also be a thick profile that will flow into the dashboard, basically, so that the forces can be transferred over from that pillar through the dashboard and then into the other side of the cabin, basically. And yeah, hope that together generates at least a good crumple zone and enough stiffness to protect the people inside or the person inside the vehicle. Of course, this vehicle is so light that it will most likely be pushed away. However, yeah, if you're pushed against something, then of course you cannot go away. So it needs to be a very strong and very safe chassis. If you look at the vehicles in this category, most of the time there's not a lot of attention to safety. Yeah, I'd like to drive this vehicle myself, and I'd like to be safe and return home to my kids. So safety for me is important, and that's why we will also do computer analysis on the chassis, and maybe even one day actual crash testing on the chassis. What we also did in this video is extend the big beam, that angled profile that makes a big beam under in the lower sections of the chassis. We extended it to the back, and that allows us to make a support for the beam that runs over the rear suspension towards the back, and basically becomes the mounting point for the rear crash support. And we need to add some gussets that go around the battery pack into that beam, so that it doesn't move too much from left to right. This new structure that we designed in is, I think, much more strong than the old system, and it's also much more simple. Yeah, which is in both things a benefit. It's less work and less material, less different materials. And yeah, I think it looks good. I will tell you that when we were looking at the rear suspension and the disc brake, we needed to clearance some of the material in that area that we just made. However, yeah, it's minimum. We will have 8 battery cells basically. Each cell has about 1.3 kilowatt hour capacity, so that means we're a little over 10 kilowatt hours capacity, with a DOD of 80 or 90%. Yeah, we're looking at 8 kilowatts, maybe 9 kilowatts of actual power that we can use. Should be plenty for a range between 30 and 80 kilometers, depending on the weather and the route you're driving and your driving style, etc. What I've done is 5 batteries at the bottom to keep the weight very low, 3 up top, and fit them basically underneath the driver, so to have the weight of the driver and the weight of the battery pack very centralized. And all the weight is in between the axles, which is also good. One battery cell basically weighs 10 kilograms, a casing 3-4 kilograms, something like that, controller and some wiring, etc. So I'm hoping that we can stay under the 100 kilograms for the battery pack in total. And yeah, so that's basically what we're trying to figure out in this episode. For the battery casing, what I'm doing is making it out of aluminum, and the bottom plate I make out of 4 mil thick aluminum, basically to have it able to absorb some kind of impact. There will be a floor of the car and a part of the chassis at some point supporting the battery as well, and the battery itself is not sitting on that 4 mil thick aluminum plate. It's floating above it, about 9 mil, so it should be able to have some impact resistance if that occurs. The advantage is also that it's quite close to the rear wheels. That helps, of course, also with the impact, or reducing the chance of impact. and the car is also very low, so it's not that many things can go underneath. It's not like a football is going underneath it, for example. And the rest of the battery pack I make out of 2mm aluminium, just to get everything very low in weight, and yeah, it's just designed to keep everything in place, and it shouldn't really be yeah, that much of a bulletproof casing, since it's yeah, built so deep into the chassis. Yeah, it's basically mounted inside a firewall, so the welding of the surrounding sheet metal of the chassis is important. It needs to be an enclosed firewall to the cabin, so that if the battery were to go bad and it would cause fire, for example, and toxic gases, that they cannot penetrate into the cabin. So that's the design is made so that yeah, basically 50-60% of the battery is enclosed by a firewall, which ensure that the gases cannot enter into the cabin. Yeah, the rest of the design of the body should allow that the smoke and gases, if there is a fire, which with this battery type is highly unlikely, but yeah, if there were to be something, then the battery, or the body panels need to allow that chemical gases to escape, yeah, which should not be any issue at all. Yeah, that's basically it for the battery pack and the layout and the design. And yeah, in the next video we will continue with the rear axle and complete that. As I mentioned previously, I want to change several things at the rear axle. One of the things is basically the main thing is the pushrod system. Currently I have a coilover system next to the chassis, and yeah, this basically does not work very well with most of the body styles, since I want to have these very narrow body styles with yeah, with basically or for example the hot rod body styles with the wheel arches. Then the spring is just most of the times in the way, and if we use a push rod we can build much more compact and much more elegant. And yeah, we have space enough to place the damper and the push rods above the wishbone basically, and right after the battery pack, and so that's what we are trying to do. Well, I hope you liked this video. I would like to thank you for watching the video, and I hope you have watched some of my other videos regarding this project as well. Yeah, for now I'm just engineering, and I'm trying to get to a point where where I can get the components together and actually start building it. For now I'm focusing on getting the details ready and getting everything made as properly as possible, so that we can actually go over to a production stage whenever a chance comes by. I will try and finalize as much of the packaging components as I can. Front suspension is pretty dialed in. Rear suspension is, most of the components are ready, but I need to assemble it. That will be in the next video. And yeah, then all the interior parts, and I want to start making some of the lights that are possible, maybe some of the levers. I want to do the hydro e-brake system, and maybe make a DIN cubby for the radio, and you know, things like that. And yeah, then we will start working on body shells. I have several concepts still in my head. And of course the hollow point body style that the red car basically that I show in my videos most of the time, that's basically the flagship of this concept, and therefore I want to be able to put that in great detail into the system, where everything is a solid body and not just a surface model. Yeah, so that will be one of the videos following after this one, where I start with the surface modeling and then go into bodies with that vehicle. Again, thank you for watching. I hope you enjoyed this video. If you do, subscribe please to my channel. Also give a like to the video, comment. If you want to wish me a happy birthday, you can also do that, of course. Thank you again, and see you in the next video. Bye bye.